Terminating decimal. What does the word terminate mean? Has anyone ever used the word terminate or heard the word terminate? Delaney? To destroy something, to get rid of something, to stop something from happening. Usually when you're terminating something, the reason you're getting rid of it or the reason that you're destroying it is because you need to stop whatever it's doing. Okay? So for a terminating decimal, that's exactly what it means. It's not a decimal that destroys, but it's a decimal that ends. So we're going to say a decimal whose division ends. A decimal whose division ends. Kind of makes sense. Are we okay with that? Terminating, it stops. The decimal stops. All right. Repeating decimal. Obviously, it means what happens? It repeats. Something happens again and again and again and again. It doesn't mean we have a repeating decimal per se, like dot, 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 dot. It means we have a number, right, that's going to happen again and again. So we're going to say a decimal whose digits repeat. And this is important in groups of 1 or more. So what that means is, like, you could have one number that repeats, like a 3333333, or I could have a set of numbers that repeat. So it could be like 85858585, or 259 259 259 259. All right. So I want to kind of talk about the repeating decimals for just a second. So some examples of repeating decimals. We're going to write those in right here. All right. And one example would be if I have 47.888888. One way to show that things keep going in English class is we write dot, dot, dot. Do y'all agree? English, we put dot, dot, dot. Well, in math, we have a different way of doing that because we're already using dots as decimals, so we don't want to use dots again. So I'm going to write equals in math. The way we'd write that. Has anyone ever seen that written before a different way? With a line. Excellent, Kayla. Perfect. So I'm going to put 47. Which 8 is it that's repeating? Is it the middle 8? Is it the last 8? It's that first 8, right? That first 8's just happening over and over again. So I'm just going to write the first 8, and then I'm going to put a bar over it. And that bar is called a repeating bar, because, guys, math people, we're not very creative. I'm going to be completely honest with you. I do not have a very creative bone in my body. Like, some of y'all are super creative, and I'm kind of jealous, all right? Generally, math people are not so creative, all right? So when we call something, its name usually makes sense. It's usually named after a person that found it, or it's just named what it looks like. So this is a repeating bar. Okay, real simple. All right, it's not a vocabulary word because I don't feel like we need to define that. All right, but we're just going to put a bar over that 8. That just means the 8 keeps going. Are y'all okay with that? Because if I had to write an 8 forever and ever and ever and ever, would my problem ever end? No, and that would not be good. All right, let's look at another example. I'm just going to kind of put a line here separating them. 0.56565656 dot, dot, dot. All right, what's repeating here? The 56. So what am I going to put a bar over? The 56. What if this was 0.956? What's still repeating? The 56. Is the 9 repeating? No. Even though it's after a decimal, does it get a bar? No. So even with that 9 there, I'm still going to put a bar, 0.956. My bar is only going to go over the 5 and the 6 that actually repeat. We okay with that? Okay. One more example. 33.333 dot, 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 because I'm running out of space, equals. What number, what's repeating here? Delaney?
The 3.
The 3. The 3 is repeating. Is it this 3 that's repeating?
No. No.
So I want us to think about something real quick. I'm going to flip this paper over so we can look at it, and it's on my screen. You do not have to write this. I just want us to think about something real quick. All right. If the first 3 is repeating, so there's my first 3. Okay with that? And then I add a 3 to it. Did that change it? Yeah. This went from 3. Now what number is it? 33. And if I add another 3 to that, now what is it? 333. And if I add another 3 to that, what is it? 3,333. So if you add a number to a whole number, it's going to change it, isn't it? So we can't have a repeating number and a whole number. Now if I have my decimal, so there's 33.3. All right. If I add a 3 to that, so 33.3, are we okay with that? If I repeat this 3 and I add a 3, did that change my 33? No. Did that change the 3 in the tenths place? No. It just added 1 at the end. If I add another 3, has that changed the beginning part? If I add another 3, has it changed the beginning? No. So, can a whole number have a repeating number? Can a whole number have a bar? No. You can only have a bar with a decimal. So when I rewrite that with the 33.33333, I'm going to put 33.3, and the bar is going to go over the 3 in the decimal. So we understand why that's where the bar has to be? Okay. All right, all of this leads up to us being able to divide decimals. Because when we're dividing decimals, sometimes you're going to get a terminating decimal. It's going to end. It's going to look real pretty. Sometimes you're going to get a repeating decimal, where you're going to get funky stuff, where it's going to repeat. Sometimes when you're dividing, what will happen is you'll get something called an irrational number. All right? Do you ever feel like your parents act irrationally? Does anyone know, what does that word mean when I say that? Or maybe you have a little brother or little sister, or a big brother or big sister, that are just completely irrational. Has anyone ever heard the word irrational?
I've heard, but I don't know what it means.
Don't know what it means? Okay, thank you. All right, so what irrational means, like if so, I have 2 younger brothers, and I can be completely honest, they were always irrational, which basically means they made no sense. All right? You could argue until you were blue in the face with them, and they would still be saying the sky is red. Does that make any sense? No. And they won't budge from that. Like they are just sticking to their guns, all right? Sometimes maybe you ask your parents, can I stay up late? And you feel like it's a weekend. There's no reason they would say no, but they say no. All right, you might not understand the reasoning. I'm sure they have one, all right? But to you, that might be irrational. You don't understand why they won't let you do that, all right? So irrational just means something that doesn't make sense where they are like sticking to that answer. All right, an irrational decimal is basically that. It's a decimal that doesn't make sense. It's a decimal that's going to keep going forever and ever and ever, but it's never going to repeat. Does anyone know of an example of a decimal that goes on forever and ever and ever and never repeats? Josh?
Like, I want to say so it's going to be like 2 numbers and then, like it's not going to be like in the same order, like 5, 6, 9, so like 5, 6, 9, 3, 4, 6.
Yeah, so it'd be like you said, like 29.56934 well, 1, 1, 9, 4, ... Did any of those repeat? Is there any pattern there? No, there's a really famous number that's irrational. Pi. Everyone knows or has heard about pi. All right, it's not just 3.14. It's 3.14 and then a lot of other numbers. I'm going to be honest. All I know is 3.14. Those are the only numbers that I've ever needed to do math with. All right. There are competitions where people have to memorize numbers of pi, and they compete. There is no whole number. It's going to go on forever and ever. They memorize as many as they can, and whoever has memorized the most correctly wins the competition. Brianna?
My cousin memorized almost all of them. He can go on for about
He can go on
an
forever?
hour.
Yeah, so there are some people that memorized, like, I think someone said that they had someone in their English class last year that memorized 74 numbers in pi. Delaney?
I know somebody who memorized 100 of them.
This is what it says on the sheet about the calculator that I got. Pi. 3.14, 159, 2953, 5898.
All right, and what that's telling you is the calculator is going to do those first, I think it's like 9 numbers in pi, but can the calculator go on and on and on forever and ever and ever? No. So even the calculator cannot do pi all the way. All right, which is completely irrational. Does it make any sense? No, not really. All right, let's look at dividing decimals. Let's see some actual examples of these. All right, all of your dividing decimals will be terminating, which means they'll end, or they'll be repeating. There will be a pattern. I just need us to be aware there are problems where it's not going to be something nice and neat and come out evenly. All right? We will not be doing those in math class. All right? In 6th grade math class. All right? So let's look at dividing decimals here. It says right here, number 1, the first number goes inside. We talked about racing into the house. The first person makes it in the house. So I'm going to put 46.32 in the house. We okay with that? It's the first number. It goes in the house. So what's going to go out the door? 0.4. So 0.4. All right? Number 2 says the divisor, which is the one at the door, cannot have a decimal. Does our divisor have a decimal? Yeah. So what I compared this to last year, it entertained me. I don't think it entertained anyone else, but I'm going to tell y'all anyways. All right. Have you ever had like a person come and knock on the door, like trying to sell something? All right. And so maybe y'all don't do this in y'all's house, but I know we do it at our house. If someone's walking up to the door that we don't know, probably trying to sell something, we'll like cut off the lights and get really quiet like no one's at home. Anyone ever do that?
Yep.
Anyone? Okay. Okay, good. I'm not alone. Thank you. Okay. So that's kind of what's happening here. Our decimal is like that salesperson coming up to the door that you don't want to talk to. Usually it's like the newspaper salesperson. All right. You know, sometimes you have people coming around to like witness to you. All right. If I don't know you, I really don't want you at my house. So, you know, so we turn off the lights and hide and hope our dog doesn't bark too loud. That's what's happening here. Do we want to answer the door to that decimal? No, they're knocking. Are we going to answer the door for a decimal? No, do not let that decimal in. So what we're going to do, because we do need to get it in, we need to move the outside, move it to the right if we need to. Do I need to move it to the right? Yeah, we can't have it at the door, so I'm going to move it to the right. The reason we're moving it to the right is once I move it over one space, now what number is at the door? Now it's 4. Now it's someone I know. I don't know no decimals, all right? But now it's a whole number, so we're good. All right? Now, let's pay attention to what it says right here with the star. It says, if you move the outside, do the same to the inside. When it says same, what does that mean? The same. Do the same. How many times did I move it? Once. So how many times am I going to move it on the inside? Once. You have to make sure they match. Everything in math is kind of like a seesaw or one of those balance scales. If I do it to one side to keep them balanced, I do it to the other. We always want them on the same level. All right? We don't want anyone stuck up in the air dangling up there, okay? Are we good? All right. The last thing, number 3, raise the decimal to the roof. You know, we talked about it like that's the house. Everyone know the dance move? Raise the roof. Okay. So we're going to raise our decimal up to the roof. You'll see me sometimes if I ask you what to do next and you don't know, I'll start doing this. For those who are watching the video, I just did a super cool dance move called raising the roof. All right. So when you see me doing this, that means, oh, I needed to put that decimal on the roof. Okay. Okay. I moved my decimal at the door. I raise it to the roof inside. Now I'm ready to divide. And when we divide, we're going to divide exactly like normal. We're going to pretend the decimal is not there because I've already put it on the roof, okay? In the past, it's been important that you put your numbers in the correct place on top. Now it's even more important, all right? So we're looking at 4. How many times will 4 go into 4? Once. Make sure you put your 1 on top of your 4. 1 times 4 is? 4. When I subtract, I get 0. And we're going to bring down the 6. 4 will go into 6. How many times? Once. Tucker, are you writing this stuff down with me? 1 times 4 is?
2.
1 times 4 is?
It's 4.
4. When I subtract, I get? 2. All right. Now we're going to bring down the? 3. All right. 4 will go into 23. How many times?
5 times.
All right, 4 will go into 23 5 times. So I'm going to put the 5 on top of the 3. Make sure that we've got it on top there. 5 times 4 is? 20. When I subtract, I get? 3. Bring down 2. Do you see how every single number I'm writing it on top? So now when I bring down the 2, 4 will go into 32. How many times? Where do I have to write the 8?
Behind the decimal.
Behind the decimal, because it has to be on top of the 2. Do you see how, as long as I've raised it to the roof, I've gone straight up, I'm putting my numbers on top of the number it applies to, it'll line up for me? 8 times 4 is?
32.
When I subtract, I get? 0. Is there anything else to bring down?
No.
No. Do I have anything left over?
No.
Do I need to do anything else to this problem?
Nope.
No. So is my answer a terminating decimal or a repeating decimal? Terminating. It stopped. Can I keep dividing that? No, we're done. It stopped. It's terminating. So when we say, do you see how I said a decimal whose division ends? That problem had a really good ending point, so we're good. All right. The next example. What number is going at the door? Or in the house, sorry. All right. 0.496 is going in the house. And guys, I'm sorry that this does not have lines on it for us to line everything up. If you wanted to write it on a separate sheet of paper, you can, that has lines. Apologize, I usually try to make sure we have them. Alrighty. Am I going to answer the door right now? No, we're not going to answer the door because there's a decimal. So what do I have to do? Move the decimal. How many times did I move it, Chris? Once. So what am I going to do in the house? We're going to move the decimal over once. Perfect. Okay. No more decimals at the door, so I'm good there. But we're not ready to let them in yet. What do I need to do? Put the decimal on the roof. It's like the song, you know, the roof is on fire. It's not on fire once you put the decimal up. Do you want someone in their house if your roof is on fire? Yeah. No. Raise the decimal to the roof, put the fire out, we're good. Okay, that was really, sorry, I kind of reached real far for that one. My bad. Okay. All right, so we moved the decimal to the roof. Now we're ready to divide. Yeah. How many times will 12 go into 0? 0. If I'm putting 0 up there, do I need to do all the subtraction? Does subtracting 0 change anything? No. Okay. How many times will 12 go into 4? 0. How many times, so I'm just keeping moving over, how many times will 12 go into 49? Thank you, Brianna, for raising your hand. 4 times. So I'm going to put 4 on top of the 9 because we were looking at 49. Make sure the 4 is on top of the 9. 4 times 12 is?
48.
48. When I subtract, I get? 1.
Bring down the 6.
Bring down the 6. Sorry. Whew. All right. So now, how many times will 12 go into 16? Once. Let's work on our hands, Josh, please. Okay. All right. 1 times 12 gives me, everyone? 12. 16 minus 12, everyone? 4. Okay, so I'm going to pause here for a second. All right. I'm out of space up on the top. Every number has something on top. I have 4 left over. All right. Y'all, I know y'all are ahead of me. I know y'all are good. Give me 1 second now, real quick, okay? In the past, when it was a whole number, we took that leftover and we made it a fraction. All right, here's my dilemma. I have a decimal as an answer right now. Decimals and fractions cannot coexist. That cannot happen. If we had a decimal and a fraction in the same number, it would ruin math as we know it. All right, which basically means all those 6 years of math that you've been learning, 7. I counted that. Y'all haven't gotten through a whole year yet? All right, so the 6 years that you have had so far, not counting this year, okay, would be a complete waste. Do we want to have wasted 6 years of our lives? No. So we want to make sure that decimals and fractions are never in the same number. Okay? They would take over the world. All right? Math would be ruined, and if math is ruined, math is behind everything. Everything is behind math, or math is behind everything. There we go. All right. So what we're going to do, since we can't make this a fraction, some of y'all had your hand up. What do I need to do to keep going, Kayla? I'm just going to add a 0. You're perfect. Excellent. So like what we were seeing earlier in the repeating decimal, I can add numbers to the end of a decimal. We can add zeros to the end of it if there's not a number. All right, I'm going to bring that 0 down. How many times will 12 go into 40? 3. Make sure you write that on top of the 0. 3 times 12 is 36. When I subtract, I get 4. When I add a 0 and bring it down, what's going to happen?
It's the same thing that's going to happen.
At the same, I'm going to get 40. I'm going to subtract 36. I'm going to get 4 again. Change it to 40. Subtract. It's going to keep doing what? Repeating. Guys, once you're adding zeros, if you can see something's repeating, I'm okay with us putting the bar, okay? Can something repeat if I'm just bringing down regular numbers? No. If I'm bringing down zeros, though, you can start to see a pattern. All right? So when I do my repeating bar, what number is it that's actually repeating? Christy?
3.
The 3. All right. Who can tell me, what am I going to circle for my answer here? What would be a good answer for this problem? Okay, that's what we wrote on top. Yes. If I read this answer, am I going to say 0.413 repeating? What sounded weird about that answer that I just read? Chandler? The zeros. Will we ever say, it's a double zero? My answer is double zero. No. So I just want to circle the 1 0 next to the decimal. Do y'all see how I'm kind of taking that extra one off? All right. I would never say, my answer to this problem is double zero. No, I would just say 0, so I only want to circle a 0. Are y'all okay with that? All right. Number 2, 45 is going in the house. This one is kind of tricky. All right, had a couple of questions about this in first period. 0.004. All right, am I answering the door to that decimal right now? No, it's a decimal. We don't let decimals in our house. Ew. Okay. So, I'm going to move it over. How many times am I going to move that decimal, Maria? 5? 3. We've got to go all the way to the other side of the 4. 1, 2, 3. All right, now we've said if we do it on the outside, we have to do it on the inside. Problem. I don't see a decimal on the inside. Danny?
Make one.
Make one. Make one, Danny. I'm sorry. How do I do that? Brianna?
You add it at the end of the decimal because it's a period.
Add it at the end. It's like a period. A period goes at the end of a sentence. A decimal goes at the end of a number. So we add it. Just like Danny said, you can just add it. All right, we just got to put it at the end. Now, can I move my decimal 3 places? Yeah, remember they have to match, so I'm going to count over. 1, 2, 3. All right, make my line a little bit longer. Now that looks a little goofy right now. Just got some empty scoops. What am I going to put in those scoops? Zeros. All right, we're ready to divide. No, my roof is on fire. What do I have to do? Move the decimal up. Y'all awake now?
Yeah.
Okay, good. All right. Your ears hurt. All right.
I was writing down the answer because I just finished.
You're-
I said, "Everything's apart."
Well, my roof was on fire until I put that decimal up there. Are we okay with that now? All right. Emma, are you awake? Do I need to be louder next time? All right. Okay, so what number am I dividing this time? 4. 4 will go into 4.
1 time.
Once. 1 times 4.
4.
I'm going to go through this kind of quickly. So that gives me 0. Bring down the 5. 4 will go into 5.
1 time.
1 time. 1 times 4 is
4.
4. When I subtract, I get
1.
bring down the 0. 4 will go into 10.
2 times.
2 times. 2 times 4.
8.
When I subtract, I get
2.
2. All right, you can see just because I'm bringing down zeros, does that mean there's automatically a pattern? No, because this time I got 20. 4 will go to 20 how many times? 5. 5 times 4 is? So I subtract, I get
0.
0. I got 0, so I must be done with this problem.
Yep.
No, you have to bring down.
Well, you have to bring down the 0 and then put the 0 up there above the 0.
Yeah, so I have 4 has a number, 5 has a number, the first 0 has a number, the second 0 has a number. Does my third 0 have a number?
Nope.
No, so what am I going to put there?
0.
0. All right, this time when I circle my answer, am I going to leave that 0 off? No, because 11,250 is definitely different than if I just wrote 1,125. So we do need that 0 in this answer. Do I have to have the decimal in my box? No, it's a whole number. If you put the decimal in your box, that's okay. All right. Are there any questions on number 2? All right, On your homework. On your homework. All right, you have 9 problems where it's just dividing. Then you have 2 word problems. A little tip for you on your word problems. If the worksheet is on dividing decimals, what are you probably doing on the word problems? Dividing. But what I want you to pay attention to is what is it in the word problem that's making you know to divide? Because on our test Friday, you're going to have word problems, but it won't just be, hey, you're going to divide on these. You'll have to decide, okay? So make sure we know why. All right, the one thing I want to talk about before I hand these out to you, there's not a lot of space on here, so where do you need to do your work? On your own sheet of paper. All right, pause. Don't get it out yet. Number 2, we didn't have one exactly like this on our notes, so I want to look at it. What number is going in the house? 22.47, and at the door we have a 7. All right, can I open the door?
Yes.
There is not a decimal at the door, so they can come in all day long. All right, before I let them in, what do I have to do? Raise the decimal to the roof. Put that fire out, okay? Raise your decimal up, and then you're going to divide this just like we did before, okay? The only difference is you do not have to move it. Do we understand why we do not move that one? There is not enough space here to work this problem. Please work them on your own paper, all right? If you work them neatly, number them neatly, you don't have to rewrite your answers on here. You can just circle them where they are, all right? But remember, if someone else is grading your paper, they need to be able to read your answers, read your work, find your answers, circle them, okay? All right, I'm going to pass out your homework before you get started.